Hi friends, welcome to my another video. This is the part 10 video in series of designing of G+4 building as per DEWA regulation. In part 8 and part 9 video, I discuss about the mathematical calculation for the MDB designing. In this video, I will carry out the topic MDB designing, but we will discuss here what is the MDB designing requirement and the MDB room designing requirement. So let's start this video. The first requirement for the MDB room is that the MDB room height shall be minimum to be 3500 mm. What does that mean? Suppose this is the ceiling for the MDB room and this is the floor of the MDB room. The clear height between the ceiling of the MDB room and the floor of the MDB room must be 3500 mm, that is 3.5 meter. This is the requirement for the MDB room related to the clear height for the MDB room. Now let us move to the other point. If the second point indicate that suppose this is one of the MDB room, okay, and it has a length of more than 6 meter, then we need two doors. One is double door and one is single door. The dimension of the double door should be 2600 height, 1500 width for the double door and 2600 height and 900 width in mm for the single door. If that any MDB room having in length 6 meter and more than 6 meter, okay, if any MDB room have less than 6 meter in length, then one double door is enough of this dimension, that is 2600 mm into 1500 mm width. Hope you are clear with this second point. Now let us move to the other point. In the MDB room, the capacitor must be adjacent to the LV room. This is the screenshot from DEWA and this one is also a screenshot from DEWA regulation. So here you see that the MDB and the capacitor banks are adjacent to each other. This is the 2 MDB room, this is the single MDB room. So here also you see that the LV panel and the capacitor bank are adjacent to each other. The other requirement for the MDB room is that in front of the MDB, the clear access to be 1.5 meter, or you can say that 1500 mm. Suppose there is 2 MDB, then the clear height between the 2 MDBs should be 1.5 meter. Suppose this is one of the photo of my project. Here there is 2 MDB, okay, then the clear access between the 2 MDB must be 1500 mm, or we can say 1.5 meter. The other point, the other requirement for the MDB room is that the rear access for the MDB must have 0.75 meter clearance. So here you see this is the front, this is the rear of the MDB panel. As I told you before, the front access must be 1.5 meter and the clear rear access to be 0.75 meter. This is all as per DEWA regulation. The other point for MDB is that the LV and MDB panel height shall be 2200 mm. The height of the MDB should be less than or equal to 2200 mm, that is 2.2 meter. At any cases we have to make the MDB height less than or equal to 2.2 meter. Here in our example, the MDB height is 2100 mm, but it is less than 2.2 meter, so it is accepted. Any MDB panel which having a height more than 2.2 meter is not allowed as per DEWA regulation. And the minimum width shall be provided for MDB incomer is 800 mm. What does it mean? Here you see there is two ACBs, one ACB and second ACB. One ACB, air circuit breaker, is for transformer and one is for generator. Both are the incomer breaker for this MDB, right? The width of the compartment where the MDB main incomer placed, it should have minimum width to be 800 mm. This is mentioned here. What it is mentioned, the minimum 800 width shall be provided for the MDB incomer. So which section the MDB incomer are placed, that section should have a width of 800 mm. So in same way, this section is also having an incomer which is fed from the transformer, so it should also have the width of that compartment should be 800 mm. Hope you are clear with this point. Now let us move to the other point. The top tire for main bus bar chamber minimum to be 200 mm, and the second tire shall be provided with kWh R meter. Okay, so what does it mean? As I told you previously, the width of the incomer chamber should be 800 mm, and in this point it is elaborating more that this is the bus bar chambers. Okay, this is the bus bar chambers. So what it is saying, the height of the bus bar chamber to be minimum to be 200 mm, and the next chamber should be for the metering, and it should also have the height to be 600 mm. Here it is indicated 600 mm. Okay, this is telling about the MDB dimensions. Other point indicating that the third tire for the main breaker installation height to be 600 mm. Okay, 600 mm, and the bottom tire for the electricity intake should have the height of 600 mm. In last 2 points I told you the width of this chamber should be 800 mm. In this point it is indicating the height of the chamber for the incomer and for the chamber which will be used for the cable termination. Okay, cable termination. Both should have the height to be 600 mm as indicated here. Okay, now let us move to the other point. ACB shall be provided in a single vertical section only. This is single vertical section. Okay, this is another single vertical section. This is also single vertical section. Okay, and this is also one single vertical section. So as per this point, what it is saying, that the ACB should be installed in a single vertical section. So here if you will analyze this section, then you will find there is only one breaker, that is air circuit breaker, and there is no other breaker. So whenever there is a air circuit breaker, okay, it should be installed in a single vertical section as you see here and here. But other breakers like MCB or MCCB can be installed 2 or 3, 4, 5, total maximum 8 MCBs can be installed in a single vertical section. But if it is ACB, only one ACB shall be installed in a single vertical section. Hope you are clear. Now let us move to the other point. Up to 400 breaker rating, ampere breaker rating, we can install the breaker in a horizontal manner, and any breaker greater than 400 mm over 400 ampere, it should not be installed. It should not be installed in a horizontal manner. What does it mean? Suppose I have a breaker, okay, and its incoming terminals are here. Suppose it is a 4-pole breaker and it is a outgoing terminal, 4-pole. So this is incoming, this is outgoing. So this way of arrangement of the breaker is called horizontal arrangement. Okay, and same way I have a breaker, 4-pole breaker. Okay, 4-pole breaker. This is the incoming. Okay, this is the incoming and this is the outgoing. Means bus bar will come and connect here, and cable from the load will come and connect here. So this is the outgoing. Okay, this arrangement of installation is called vertical arrangement. So any breaker are installed in a horizontal pattern, okay, it should have a rating less than 400 ampere, and any breaker which having the ampere rating greater than 400 ampere should not be installed in a horizontal pattern, but it should install in a vertical pattern. Why? Because in the horizontal panel, for the greater ampere rating, it is difficult to connect the cable, but in the vertical pattern, it is easy to connect the outgoing cable for a greater rating of the breaker. Hope you understood this point. Now let us move to the other point, which is very important. The first point says that 16 ampere to 160 ampere can be considered as a frame size of 200 mm, and for the breaker rating of 200 ampere to 250 ampere, the frame size can be 250 mm, and for the breaker rating of 300 ampere to 400 ampere, the frame size can be considered as 300 mm height. What does it mean? As you see, this is the single vertical section which have many tires: tire 1, tire 2, tire 3, tire 4, tire 5, tire 6. Okay, and here you see each tire have different height. So how the height of the tires will decide? It will decide based on the breaker rating. These all point indicating the height of the frame size depending on the breaker rating. So when the tire size is 200 mm, then that tire size suitable for the breaker rating of 16 ampere to 160 ampere, and when the tire size is 250 mm, then that compartment is suitable for the breaker rating of 200 ampere to 250 ampere. In same way, when the tire size is 300 mm height, then this compartment is suitable for the breaker rating of 300 ampere to 400 ampere. The other point mentioned, in the multi-section enclosure, maximum 8 tires only to be provided. This I already told you. In a multi-section, maximum we can go for 8 number of tires. For this example, we have 1, 2, 3, 4, 5 and 6, but we can go till 8 tires. But with same together, we have to also think that the panel height should not increase more than 2200 mm. Hope you are clear. Now let us move to the other point. As per this point, the plinth height for the LV panel shall be 100 mm. What is the plinth? This black color you can see here, it is the plinth base support for this LV panel. It should be of height of 100 mm. And as I told you, the panel height from top to bottom including the plinth should not exceed more than 2200 mm. Okay, now let us move to the other point. For front cable access panel, 400 mm with cable chamber shall be added beside breaker section. There are two type of panel. One is front access panel and other one is rear access panel. Okay, in the front access panel, what is saying here, you see there is a cable compartment here. So this point is saying, suppose we don't have access from beside of the panel, from the behind of the panel, then that panel should be front access panel, and here the cable will come and terminate. Here the cable will come and terminate to the different circuit breakers. So the width of this cable compartment should be 400 mm. This is indicating this point. For the rear access panel, this is also a front access panel, but in the rear access panel you will not find this cable compartment because all the cable will be terminated from the behind of the panel. In that case, the panel depth should be 800 to 1000 mm, that is 0.8 meter to 1 meter. It is indicating here. The other point related to LV switchgear is that the trench width shall be 600 mm and deep to be 950. What does it mean? Suppose this is the trench for the LV panel, and once this trench is finished, the LV panel will place over it. So the depth of the trench should be 950 mm as it is written here, and the width of the LV trench minimum to be 600 mm. It can be anything more than 600 mm depending on the panel base or panel depth, but it should not be less than 600 mm. It can be 700 mm, 800 mm, 900 mm and 1000 mm depending on the panel depth. I'll show you. This is the panel depth. Suppose I have a panel depth of 800 mm, then the trench width of 700 or 800 mm is enough. But if the trench depth is 1000, then we need a trench width of 1000 or 900 mm. Okay, little smaller or equivalent to it. But the depth of the trench, this is the depth. Okay, depth of the trench to be 950 or above in all cases. But this will be valid, the depth of the trench will be valid when the LV room is in the ground floor. In many cases the LV room can be in the basement. Okay, basement. In that case the trench width can be 500, means this depth can be 500 because we don't have more clearance in the basement. So we have to reduce the trench height in order to have the more clearance for the LV room height. Apart from that, the MDB shall be form for construction. If you want to know in more detail about the form of construction for the panel, watch my video. I uploaded 4 parts and I discuss form of construction for the panel in much detail. So watch that video. But for a brief, form of construction is deciding the number of compartmentation and how each components of the panel is separated from one another. As you see here, the breaker is separated from the cable chamber. Okay, and each breaker is separated from each other through this compartmentation. So based on the degree of compartmentation, the form will be decided for a electrical panel. The other point mentioned, if we add all the breaker rating of one multi-section, it shall not exceed more than 1600 ampere. As we seen, this is the multi-section compartment, and all breaker rating, let's say it has 400 ampere breaker rating, 350 ampere breaker rating, 160 ampere breaker rating. All the breaker rating together should not exceed more than 1600 ampere. It should be less than. In a single multiple section compartment, it should not reach more than 1600 ampere. Hope you are clear till here. Apart from that, in the LV room there should be an emergency light, which is mentioned here, which should be 3-hour backup. Okay, there should be FM200 fire protection system. Here we cannot provide water sprinkler because it's an electrical room, so there will be a FM200 type fire suppression system shall be provided in the MDB room, and there should be a fire extinguisher near the door of the LV room. Okay, these are the basic requirement for the LV room. The other point is that the MDB panel should have a 42 IP rating. If you want to know what is IP rating and you want to know in more detail about the IP rating, I have already uploaded one video related to ingress protection. Watch that video, you will get more information related to ingress protection. But for the brief, the IP rating 4 indicates that first digit indicates protection against solid and second digit indicates protection against liquid. So here 4 indicates that any solid object which is greater than 1 mm cannot be go inside that panel, and 2 indicate that the panel will be safe if there will be a vertical dripping of water. Okay, so for the inside room there is a LV panel, then that should have a IP rating of 42. Apart from that, the height of the MDB room from the finished floor level to be 300 mm. Suppose I have MDB room, okay, and around it there is an area. This MDB room to be at least 300 mm elevated from the other nearby adjacent area, because if there will be a water accumulation, it will not enter into the MDB room if it has a 300 mm elevated floor. Hope you are clear. MDB shall be air conditioned. Okay, this is very clear. All the MDB should have the air conditioning because the LV panel will generate heat and we have some ambient temperature to run this MDB panel. For that sake, we should have always a air conditioning in the LV room. One more point mentioned for the LV room is that, or MDB room, is that we have one MDB room. Above that floor there should not be any wet surfaces like toilets. Okay, if there is, then we have to provide the attic slab. That will be a discussion of another topic, but time being, understand that there should not be any water wet area above the MDB room. Other than that, beside the wall which is sharing to the other room should also not have a wet area like kitchen, toilet or any pump room. Okay, and LV room should not be under any staircase. So these are the things we have to consider during selecting the area of the LV room. Okay, this is all about the MDB designing. I hope you enjoyed this video. If you really like this video, then please give thumbs up and subscribe to my channel. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.